All right, so let's look at a harmonic motion example. So example 1, given a mathematical model of d of t, so our distance at time t is equal to 6 times cosine of 3 pi over 4t, we want to find the maximum displacement, the frequency, and the distance away from the equilibrium at time t equals 4. So in this case, we're going to be finding the maximum displacement, which is going to be our amplitude. We're going to be finding the frequency, which has to do with our period, and we're going to be plugging in t is equal to 4. So in other words, we're going to be plugging in 4 for t, and then solving to find out how far our displacement is actually going to be. Now, one thing to note here, it doesn't ask you, but it's good to keep this in mind, is since we are using a cosine, this tells me that if we were to actually look at this at time t equals 0, this would be displaced from somewhere other than the equilibrium. So again, it doesn't ask us for something like that, but based on the fact that we're using cosine, I should know that. So if I were to happen to ask you that on a quiz, you would know that this was displaced somewhere other than the origin point. So let's look at this. The maximum distance, or the maximum displacement, is going to be equal to our amplitude, which in this case is going to be 6, because that's going to be based on our knowledge of the model. So again, we have this constant multiple out front, which is going to change our amplitude just like it did when we were doing a translation of functions. In the same way, we're going to know that frequency is equal to 1 over period, which in this case is going to be omega over 2 pi. And in this case, our omega is 3 pi over 4, giving us 3 pi over 4 divided by 2 pi, which our pi's are going to cancel when we do our multiplication, giving us 3 over 8 cycles per second. So our frequency is going to be equal to 3 over 8. And then the last thing that we need to think about is actually plugging this in. So if you think back to your function notation, we're going to write this as d of 4 is equal to 6 cosine of 3 pi over 4 times 4. Because remember, anything that you have in here gets plugged in for your value. So we have a t and a t, so we plug this in 4 and 4, which gives us 6 cosine, our 4's cancel, of 3 pi. Cosine of 3 pi is going to give us -1, so 6 times -1 is going to give us -6. So this is kind of a basic example of some of the things that I could ask you given a mathematical model of a harmonic motion function.